which is the bad part. Like, come on, YouTube. Okay, now it's starting. Now it's starting. See, this is what I don't understand about YouTube. Now we're able to have the chat up. Let me test this. Test. That's the correct chat. We good, chat. Chat, are we good? I don't want to sound like one of those streamers, guys. No. No. Chill gaps. No, that's the wrong one. Small gaps. Oh my gosh. So yeah, today guys, we are gonna be chilling with coding. As you can see here, we have, if my mouse will connect, we have here the thingy majiggy. I don't know where we were last time. 556 on the video. Set up the test data set. I don't know what that was all about. But we're gonna figure it out together and talk and chill as we do it. And really just, yeah, and sorry, you guys can hear every single noise that I make. I'm sorry about that, guys. I'm sorry about that. This is the ASMR mic. As you can see, it's very ASMR-y. Maybe I should get an ASMR mic. Who knows? I'm sure you guys would like it. I need my glasses. I need my glasses. Yeah. You know what? Like, I don't know what project I'm gonna do after this, guys. So I got this, AI bit here, but I'll need to invest in another GPU, a proper GPU to do proper AI stuff. So, it's gonna be hard. It's gonna be hard. I'm gonna need to. The thing is, though, like, I can't afford a 1590. I probably don't even need a 1590, maybe like an A600 or T1000 or something, one of those ones. But those are still quite expensive as well. I just need them CUDA cores and the memory. I don't need anything else. Bum 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 bum. Alright, here's the lo-fi girl that you guys all love. Yeah. Oh, the sweet, sweet lo-fi. Whew. Man. I'm trying to find a video. What was the video called again? To make Gen AI PyTorch hyphen. Here you go. Alright, so that setup function there, that was regarding this. So you needed to Um, excuse me. I'm so sorry, guys. We needed to set this up. So 556 set up the database on the video. And then so close that as well. I don't want you guys to see my text. Need to close the Discord. Oh, no Discord here. Sorry, boys. No DM leaks today, boys. Stage equals fit, so we're gonna need to call. If I look at the video here. So this is assigning the training in datasets, but didn't we already assign it? Yeah, we already did assign it, didn't we? I guess what we're doing is setting. Here we go, the train data. So this one has, let's see, self dot data directory. Where is this coming? Being used, okay. Okay, so this is relating to itself. Okay, got that. So itself.dog train, I'm guessing. So we're gonna not do this. Alright, so we're gonna do set up. So there's gonna be cold. Yeah, so this is gonna be self if assign test data set. So this is gonna come from the dog data module. Where's the dog data module coming from? I want to see. So dog data module, dogs train combined. Actually, I forgot what the data structure was. So I'm gonna do a pass. I'm gonna do a pass here. I'm gonna do this, and I'm gonna do a pass here. We're just gonna run everything because I need to. It's been a while. I need to see, yeah, stuff. This may take a while, this part. So dog vowels combined. I love this. I really love this. Because I think, hopefully what my understanding is correct, but my understanding is that this is being stored in the RAM instead of the VRAM. So saving VRAM, hopefully. The precious VRAM. They might be like, but Gabs, VRAM is much faster, boys. VRAM is expensive. I don't have VRAM. I only got 4 gigs of it. If we continue with the datasets and just add more and more of it, it's gonna be gonna be very expensive. I don't have enough for a 1590. I'm a broke post uni boy. Working what's it called? A thingy come in what's called me low wage job. But yeah, slowly guys, slowly we get there. After we do this project, we're gonna get started on another project. We're gonna get started on a web development project, guys. That's what we're gonna do. Look at my GPU work. Work GPU work. Oh wait, no, that's the wrong GPU. Okay, this one. Work GPU work. 3D encode, yeah. That's it, baby. That's it, baby. Work it. Once I get a good enough GPU, guys, we're gonna start doing some LLMs, guys. That's what we're gonna do. We're gonna start small with the LLMs, and what I want to start creating and what I want to start making is LLM and then adding personality into it. You know, personality structure. Because LLMs are just probabilities, but what is the probability that that the thing is nice or something, you know? So we're gonna actually go in there and have some weight and biases and all that sort of stuff. So it's not gonna be just like you feed an LLM a manual and all that sort of stuff and then just reads it and like a usual chatbot. No, it's gonna actually have feelings and emotions. And you may be like, but Gabriel, it's just a robot. And my thing is are we not all probabilities? For example, if you push me hard enough, am I not gonna be annoyed? Like, what's the probability of that? You poke me, am I not gonna be annoyed? Alright. It's like the quiet kid at school, you poke him hard enough. What's the probability that... Never mind. Anyways. So we have... Alright, so... here is what we're dealing with. Just for 1 dB, we're gonna ignore that. Instead, so create data loaders and all that sort of stuff. Okay, that's bad. That's bad as well. Okay. Were we setting the test data? I guess we're not really setting the test data, are we? Well, this is an issue. Okay, here we go. His train is based on this. So this is being changed based on the create combined list. Where is that? Create combined list. I need to find that. Here we go. So dogs val combined is supposed to be false, but oh yeah, okay, cool. That's good. That's correct. That's false then. All right. Yeah, that's correct. Da 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 da. And then we have the combined list. So there's something bit of an issue here. What were we doing last time? Self-load data directory. Okay, here we go. We are passing the train and the val. Okay. So did we need setup? Probably we did need setup. But this is interesting. How did we prepare the data? We didn't prepare the data. Okay. Okay, no. So we've got the train and we've got the val. Now what we actually need is just the... No, okay, here's the issue. Okay, no. Okay, so What does it test me? Oh, where are we getting that from? I should open up Colab. Okay, so the stage, where is it set up? So dot setup staging is equal to, okay. I don't think we need to worry about that for now, but set up for we're gonna try to do it like the thing. Here's the thing, we've already gotten the train and the validation data. Train, because we just need to test. Or can we get the combined data? No. No, we're gonna change this back again. We're gonna change this to data. I think this one states it with the data directory, right? Yeah, data directory. But because the way that we're doing it, the data is in subfolders and all that sort of stuff. I'm so confused. Just so we'll prepare the data outside. That's what we'll do. Here we go, we'll do untouched DF. So untouched DF is gonna be the DF that is untouched. So assign test data set. No, you know, I'll just get rid of this. No, I don't know, man. We'll see how it goes. Oh, yeah. Hmm. Thing with this is that we don't know the min's data. We don't know the structure of it, as in like the function is different. If we look at the min's data, right? Not this one, not the min's data module, but the min's object, the min's class. We don't know what sort of data it's inputting and how it's inputting it, so because we are having a different sort of data structure, we need to, I guess, no, no, I think what we can do is that we can just do this data. We can just do self.df equals df. So this is going to be df. So df is going to be the raw data, frame. So this is going to be df. We're going to do this as what is called the pb dot, is it pb? No, putty, no, not pytorch. pd dot data frame. So that's one thing. Batch size is gonna be int, and worker is going to be int. Making sure that we're understanding. Wait, what is going on here? Huh? What? I'm not making a new column? What is going on? Int is not accessed by PyTorch. What is going on here? What is this? Okay, there we go. So now you guys might be wondering, Gabs, why are you doing it like this? Why are you being so careful? Because guys, later on I'm gonna forget all about this and I'm gonna need instructions like dog data module. Okay, I'm not looking at it, right? I'm looking at dog data module. We go to dog data module. let's say all the way up here, all the way down here. And, you know, we just go this dog data module. The thing is I want to see this, so I want to see what exactly it is that we're putting in. That's easier to realize, hey, this is not spaghetti code. Well, it is sort of, it's not spaghetti code. There is structure to it. There's a reason why there is structure to it, you know what I mean? So, unlike this one, I would say don't do that one, but make sure that it's implemented like this. And then we can just go this and this. Df, the raw data frame that contains the tensor, that contains the tensor for each image, the tensor value pre-calculated for each image as a column, where each image is a row. Cool. Batch size, the number of, I don't know how to say this. I understand the concept of batch sizes, but I don't know the correct term to use in this. Batch size, number of blocks of data we want to process. Number of workers, the number of workers that will be used to process the data. So self.df, batch size, number of workers, train data. So we're gonna first of all we can't. So hold on, turn on the light, guys. So, define setup self stage equals none, and then assign the train val data sets. If stage equals fit or stage is none, or stage is none. Then if stage is equal to fit or stage is none. Self dot train df self dot train test df is equal to now we got to search up how to random split a what's it called, pandas data frame. Okay. This is you know, maybe I should make a what's it called, a random thing that can just do this, like pd dot split. PDS.pd split. Oh no, I should call it PDS panda split. Or PDS squared, PDS2. I don't know. So creating a data frame, 25% values of the original data frame. Okay, so drop part. Okay. So splitting the pandas data frame randomly, assigning the results of the split data frame. I guess this is so we don't have to handle 2 whole data frames, which is quite a big load. So part 50 So part 50. Wait, what am I doing? No. So self.train df equals df.sample rack equals 0.5. So this is going to be self.df and we're going to call it main df. No, we're going to call it original df. Should we call it original df? Self.df. No, we'll just call it self.df. Self.df. And then self.valdf is equal to self.df.drop. And then we're going to do drop train df. Drop self.train df dot index. And then we should receive it, I think. So after we log the dog data module, just have that. This does change a lot of stuff though. So this does mean that actually we don't need that thing before. So if we go all the way up here, we don't actually, in fact, it would be bad if we had this combined thing. You see this combinedness here. So this would actually be a bad thing. And instead we should just have a combined list. Create combined list. So here we go. Yeah, create the combined list of everything. Oh no, wait, no, no, wait, what's going on? No. Okay, random split. Okay. Oh, why am I splitting it randomly by that? I wonder what did I do? So I'm splitting the data into, I don't need to split the data though. Dogdf. Okay, so I need to re-edit my code because now we have it in this, which is much better in so many ways. Because this is all handled in one and handled properly instead of this weird junk. So I need to first get rid of this. Get rid of the is train. So is train. Get rid of that. This is where we're creating the database. So we want to get rid of that. Yeah. Click run this. Here we go. Combined. Bum. No, that's not it. Calculating. That's calculating the mean. Calculate the mean. Shoot, did we need to? Oh, is this why I did it? Oh, wait. Nah, man. Nah, bro. How I know? I hate this. Oh, I did not see this earlier. No. Wait. Wait. No. Can still be done. It can still be done. This can be... Will this work? Is what I don't know. So... It'll be very, very bad. Is train false? Is train that's removed. Is test data. Insert. So just have dogs. EF. Alright, here we go. That's not right. No, hold on. Get rid of this. Oh shit, I just realized something. Maybe this is... Maybe we're taking the wrong approach. I need to run this. No, it's just the classes, so we don't actually understand. Oh no. There's no actual thing. Well. Alright, so that's self.transform inside of the things. I'm a bit of digging. The self.transform is not actually really required for us at the moment, or really at all, since we've already did we already do transform image to tensor? No. Okay, so we have just done value takes the image direction, return the images tensor value. Additionally, this obtains a random resized crop of the image. Ensure that all image tensor are the same shape. It's the same shape or same size? I don't know. I forgot. I know they're different, but image directory. This is gonna be a string. Okay, so the tensors from this still need to be normalized. So we still need this one. So we'll need this. So if this has not been... So if we're not able to do this... Right, if we're not able to calculate the mean as to the data set, and passing self-train and all this, because of course setup it's not been, it's called setup has not been done before, therefore, you know, self-train, self-val and all that have not been made yet. Then we will make self.setup at this point of the code, self.train df and self.val df are initialize to use them, and then you can do self dot main self dot std equals, and then we can actually call upon this one. So we need to fix that. It's not properly set in stone what it is receiving. So let me just train combined. So train the F. Val df. df. This is a torch dot 10 no pd dot data frame. So the pd dot data frame. So now we're able to call upon transforms. And this is self.df. And you know what? This really is going to become spaghetti code if I do that though. I don't know. I cannot make spaghetti code. I need to make sure it's all linear. search up. Hold on. Okay, we're gonna need to do a Lambda operation. Maybe. No, we can do a... Okay, come on, tell me how I get the specific color one. Oh my gosh, this is gonna be hard. Ay. To each column, I want it to be a specific column though. Y and B square. Okay, df dot sample dot apply transforms self dot train df equals self dot train df dot apply df okay, dot image, what was it called? Image tensor. So image tensor dot apply, and then we're gonna do dot apply self dot transforms dot apply self dot transforms. So I want to do that, and same with this self dot oh my gosh, self dot train self dot val and self dot val. So this will actually apply the transformations, and this one too will apply the transformations. That we can do df dot and df test dot df image tensor apply self dot transforms. Cool. I'm gonna restart this so I can have fresh, everything is fresh, all the variables are freshed and flushed and everything. I'm gonna run from the start as well. You can see if there's any issues, but this should transform and everything. Yeah. Hopefully. Unless we messed up. Oh no, I forgot to... Hold on. No, it should be fine. This should be fine. Yeah, okay. Now, where are we at in the thingy? Display docs DF. This will fail. Yep. Okay. Okay, that was the tester there. That was just a tester. Calculate mean STD. It's not gonna calculate mean STD, which means we have to do a dog data. Dog test 1 equals dog data module. Okay, so this is going to need to be lower on the hierarchy so that we can we're gonna call it doggy. It's dog data module test. First we'll load this up as well. Okay, that's good. Let's load it up. Can I get a... Let's see, is this probably done? Yes, cool. Alright, this is gonna be our first big test, guys. Our first big test. Kind of. Actually, I want us to print the self main is main self.main and std is self.std. And I want this to be printed twice, please. And make sure that we're getting the stuff. Because we're not gonna be able to get it here, but we will need to do this now. We will need to initialize this, so we're gonna need to initialize with df. What did I name it before? Dog df. Right, did I call it dog df? Dogs df. No, I'm gonna call dog dog data frame. I just messed myself up for a whole big world of waiting, but do that and then do this. Oh, that's gonna take a while. This is why we have the lo-fi, guys. This is why we have the lo-fi. Yeah, so we do that. So we're gonna call dogdf, and then this is gonna be batch size is equal to what? 28? Come on, man. Finish already. Come on, dude. Finish. Batch size 12. Number of workers equals 2. How many workers does this guy put in? Batch size 128. Number of workers is the integer. Okay. Hold on. Batch size and number of workers. Okay. Nope, this is done. Center. Cool. Match size and then number of workers. Oh, we actually don't need to put it, so we just need to put dogdf. Okay. That should automatically take it from the stuff. Alright. So dogdf. What is this? Doggy. Attribute transforms. Self transforms. Where is this? Self.setup. Okay, so that self.setup. Self transforms is not available and it's not a thing, so okay. I see what the issue is. Alright. Okay, so we're gonna need to set it to initial setup. I'm not liking the way this is, because that might impact that is going to impact the data. That is. We're in a bit of a loop pickle here. I'm not sure what to do about it. How we can proceed. Let's look again at how it is that we... Oh no, what did I do? Let's look at calculate the mean. So calculating the mean STD. Okay. Initial setup of... Okay, so this is initial setup. Initial call equals false. Okay, so initial call is equal to false. So what is initial call? No. Set up the train df, val df, and test df. Initial call it's going to be is with the initial is the initial call made to make the object? If so, then set value to true. This will then skip over the normalization step as we need the initial data frames to obtain the mean and STD values. Cool. So if initial call is equal to true, is equal to false, then we can apply this. And this one here, if initial call equal to false, then we can apply this. Alright. And here we will be saying that the initial call, so where is it? Where we set up. There we go. Initial call is equal to true. Cool. So that'll skip over that. So if we do this, that's good. And we do this. Cool. Alright, so we have the mean. We have the STD. Oh, I'm so tired. Guys. And now, what I want to do as well is fetch a new table. So I want to do dog, do doggy dot self train, doggy dot dog data self dot train. Oh no, not that. No, doggy, no. Not that one. How did I... Doggy, how do I access this? How... Doggy dot... Train DF, okay, okay. Can we go display? Can we go doggy? Can we display doggy dot train DF? I want to see this. I want to see doggy dot train DF. So we were doing the test, we're comparing this, right? Dog DF, so... Oh, no, hold on. No, wrong. We should do... Test. No, we should do... Test. Yeah, test EF. Yeah, there we go. Alright, there we go. I guess test EF should have the entire thing. Guys, I want a dog. You know... Oh. You know, I'll show you guys pictures of dogs that are really, really cute. No, never mind. We already did it. Let's see. Beagle 1 Tensor 3. Alright, now that's been normalized. Oh, what did I do? Okay. Now that has been normalized, training data loader and all the rest. Yep. Batch size. going to be self-dot batch size. Number of workers is going to be self-dot number of workers. This is the easy part. Copy. No! Shoot! No! Okay. Imagine if I accidentally just pressed start on this again. Bro, that'd be so painful. Okay, so there's the test data loader. Test. This is the val data loader. Val data loader. So val data loading. Yep. Oh my gosh, guys, we finally did something. Yay! Create the setup in data loader. Okay, so this was already done. We can get rid of that. Get rid of that. Actually, I do want to never mind. You can get rid of that. Okay. Oh, okay, so I'm reading the thing. What is that? And apparently what I can do is I can just copy this. Copy the discriminator class by the looks of things. Yeah. Copy cell. So we can. So this one is very, what's it called? At the moment, just as is. Like this is the backbone of it. So this is not as hard. We don't have to edit much. Hopefully in this one we don't have to edit much. I don't think so, because everything's already tensored up. And yeah. Cool, cool, cool. Alright, so now we can just go. Oop. No, I need to figure out what a dropout layer is again. How does the dropout layer work? Because this is something that I had an issue with before, so we're gonna hidden layers and dropout layers, man. Some of them are just like, huh, in class. I was just like, huh, you know. It was horrible, bro. You know what I see with a dropout layer? All I see is saving VRAM, boys. Okay, so this is dropout layer. Okay, but we don't know the dropout layer. What's the... Can I get the thing? Is that half dropout? Yeah, okay, so it is a probability of probability of 0.5. So half of these will drop out, so we'll go back to 10. But why in the world is going to... So 1 to 10 connections, 10 to 20, 20, half of those are dropped out, and then why in the world is it 320? What in the world? Why in the world is it 320? How do linear layers? Hold on, convolutional neural network layer, linear layer. Here's the equation. Okay, wait. There's an explanation there as well. So, convolutional, fully connected layer. Okay. So I gotta search up what is a kernel size PyTorch. no. Convolutional neural networks. Okay, the values in the cut. Okay, yeah, but the size. What are the size? What determines the sizes? The specific size that we need to put. I don't think so. No. Okay. Alright. Man, Gigs for Gigs is the best, bro. Gigs for Gigs is one of the OGs. And linear. Con 2D. Let's see, 50, since this is an image, 20 cubed? Is that what we're calculating? 20 cubed, 20 to the power 3. No, that's 8,000. What? How are we getting? No, 20. 10. 10 cubes into a drop-in. 10. No, that's not it. Covenant shape calculator. With 100 height, 100 channels, dimensions basically. So 3K is kernel size is 5. Strategy padding. Oh yeah, we might need padding. And 5. Okay. Yeah, I don't know. I don't know. Hey, we do input, then 20. Nah. Okay, we're gonna use the default. Can't figure it out. But we're transferring it all back to 1, basically, guys. That's basically what's happening. How it is transferring from 10 to 320, I have no idea. Okay, it's a number of in features. And what is this one? Number of out channels. But how do you get... How do you... Huh? I don't get it. How to determine the number of in features for and linear. Hold on. I'm gonna have dinner, guys. Hello guys. Hello. I am back. Nice and chill. Okay, let's change this. Oh shoot, how do we change this? 1 by 28 by 28. 28 times 28. We didn't change that. Oh gosh, it's gonna be a pain. The color, this, conf 2D in channels. Can I get that? That is in channels, out channels, in channels, out channels, kernel size 2. And then channels. Okay, latent dimension 256. So 28 times 28 is what? I need a calculator for this. 28 times 28 is 784. 784 now. Give me another calculator. 7 times 7 times 64. 431 first. Oh my gosh. How do we calculate the latent dimension of the linear? In features. Like in dimension. Okay, but what is... I am so stuffed. Okay, hopefully this will be alright. Notice if there is an issue. Okay. I need to look it up here. Ah, but that doesn't make sense. Again, why are we... No, we need to do dimensions to conf to the... Alright, so with 100 channels, channels 3 and 5, 2, no, we'll keep it a 3, the stride is 2, 0 padding. 5 channels, 49 times 5. Okay, now if we do 28 28 2 14 5. Why is that? Maybe we need to work in reverse. Fire, that's the hard part of this. YouTube. Oh my gosh, Dixie! Guys, it's Dixie. Dixie Doo. Aww. Aww. Man, this is peak wholesomeness. Ah, so cute. The cat. He's hungry. Wait, is Save the Fox live right now? They're alive. Are they live? Is they alive? Oh, then Cam. Okay. Then Cam at night. Yeah, that thing is sad there, that little bit there. Hmm. It's sad to see a fox lose a dead tail, you know. And it's so cute though. Wait! Are these baby foxes? I didn't know they had birth. Oh, that's so cute! Oh, that's so adorable. Oh. Man, this is so wholesome. Guys, when I start my own gaming company and all that stuff, right? It's gonna have a fox logo, thanks to being inspired by Reptalia, right? Reptalia. And then we're gonna donate money to Fox's places. One of them is this place, Save a Fox, and another one I think there's a sanctuary in Japan that does stuff as well with foxes. So Save a Fox and one in Japan as well. None. Alright. Oh my gosh, alright, this is gonna be... I'm gonna need to relearn a lot of the theory. This is deep, this is deeper into deeper. We'll improve this later. Note, change learning road to Adam. Later on. later on. By the way, if you guys wonder, I'm watching the YouTube video to understand how to do this. Oh my gosh. Wait. Okay, up. Optimizer IDX. This is not good. I don't see this specific one. Bro, you didn't put that. Oh my gosh, no. You didn't put that in the what's it called? uh No, no, it's way more difficult than that. Okay. Alright, let's go make this from scratch. Z equals self dot validation Z. This is already gonna have issues because we're not starting with that. This, I'm gonna. gonna fail. Oh, in which I'm just gonna go to sleep. I'm gonna be falling asleep, man, as I wait for this. Oh shit! I figured out what. No. Okay, there we go. And Ronald. gosh, it's taking a long time. What is going on? Sleep. Alright, something works. Something is working. Okay. Up to here. Up to here and the 8. 4, 25. 9. Video, okay. I'm gonna end it there, guys. 9, 12 video. Time to back up the work. Alright guys, thank you so much for watching. I'm tired. I hope you guys are doing well. Been 3 hours and 25 minutes, oh my gosh. Usually I take breaks like every couple of hours, even with lectures, but oh my gosh. I didn't wake me. Anyways, enough studying for today at the moment, guys. Thank you guys for watching. Hope you guys had I don't know, time. I don't know, just hope you guys found something useful out of my blabbering. Thank you guys once again, and hey, next time we'll be doing some gaming stuff on the main gaming channel, as well as we're gonna be doing some voice acting, guys. That's right. We're gonna be doing some voice acting. Uh-huh. We're gonna try and get Cuddly Boyfriend started because hey, boyfriend experience, right guys? Right? Boyfriend experience right there is some of the best stuff. Just like girlfriend experience. Makes people happy. Anyways, good night guys. We'll see you next time. Bye bye. Cheers. Bye bye.